Hello everyone. Welcome to today's session on vulnerability assessment of Docker image. In today's session, we're going to explore one of the most important aspects of container security, vulnerability assessment of Docker images using Trivy. We'll start with a short theory section to understand Docker, container security risk, vulnerability assessment, and why scanning images is important. Then we'll move into hands-on lab where we'll scan both a clean and a vulnerable Docker image, analyze the results, and see how this knowledge helps strengthen container security. By the end of this video, you'll have a clear understanding of how to assess Docker images with Trivy and why it should be a critical part of your DevOps workflow. But before you move on with the session, make sure that you have subscribed to IP Specialist on YouTube and don't forget to hit the bell icon for updates. So, what is a Docker? Docker is an open source platform that helps you build, package, and run applications inside a container. A container bundles an application with everything it needs: code, libraries, and dependencies. So, it works consistently across any environment. Think of containers like shipping containers. They carry goods safely and consistently, no matter which ship, truck, or train moves them. And unlike virtual machines, containers share the host operating system kernel, making them lightweight and fast. Docker images act like blueprints or templates, while containers are the running copies created from those images. Images can be stored in registries like Docker Hub and used on any system. And developers create them using Docker files that define the build step by step. Because containers are isolated, multiple applications can run on the same host without interfering with each other. They start quickly and they consume fewer resources compared to virtual machines. In short, Docker makes applications portable, consistent, and easy to deploy in any environment. Now that we understand Docker and containers, let's explore why container security is so important. Containers make applications portable and easy to deploy, but that convenience can also hide risk. Base images such as Ubuntu or Nginx may contain outdated packages, and even a single vulnerable image can introduce risk across many systems. Misconfigurations such as running containers with root privileges increase the potential for attacks. If vulnerabilities go unnoticed in production, attackers could steal data, disrupt services, or gain control of systems. This is why container security is essential. It ensures that the benefits of speed and portability don't come at the cost of safety. With the importance clear, let's dive into some specific security risk container faces. Containers have unique security challenges. Some common risks include using base images with outdated or vulnerable software, downloading images from untrusted sources which may contain hidden malware, running containers as root, giving attackers more control if they exploit a vulnerability, unpatched libraries, weak networking setups, or exposing services directly to the internet. Then accidentally storing sensitive information like API keys or passwords inside images. Since containers share the host kernel, a single escape can compromise the entire system. Now, understanding and managing these risks is crucial to keeping container environments secure. Now that we know the risk, how do we proactively find and fix these vulnerabilities? This brings us to the vulnerability assessment. Vulnerability assessment is the process of scanning and identifying weaknesses in a system, application, or container that attackers could exploit. Think of it like a health checkup for your software. It helps detect outdated packages, misconfigurations, or missing patches before they become serious problems. In the context of containers, even small vulnerabilities inside a base image can compromise the entire application running on it. Now, once we understand vulnerability assessment, the next step is to see why scanning Docker images is critical. Now, even though containers are lightweight and portable, the images they are built from may hide security risk. Base images can contain outdated packages, known vulnerabilities, or misconfigurations. By scanning Docker images before deploying them, we can detect issues early, prioritize fixes based on severity, and prevent insecure images from reaching the production. Regular scanning ensures that containers remain safe, reliable, and compliant with best practices, giving developers and DevOps teams confidence in the applications that they ship. Now, to make this process simple and effective, we can use a tool called Trivy. Trivy is an open source tool that helps scan container images for security issues. It checks not only the operating system packages inside an image, but also application dependencies, making it a comprehensive vulnerability scanner. Trivy can detect outdated libraries, misconfigurations, and even secrets that may have been exposed by mistake. The best part is its simplicity. You just provide the image name and it performs a complete scan, organizing the results by severity levels such as low, medium, high, and critical. Each finding is linked to a CVE or common vulnerability and exposure. So you know exactly what risk exists and how it could be exploited. Because Trivy is lightweight and fast, it fits easily into development in DevOps workflows. Next, let's see how Trivy helps us put vulnerability assessment into practice. Trivy doesn't just identify problems, it helps you prioritize and fix them. Vulnerabilities are categorized by severity, making it clear which issues need immediate attention. It provides detailed references, including CVE number and links to patches, so developers know exactly how to remediate risk. Beyond individual scans, Trivy can be integrated into CI/CD pipelines, ensuring every new image is checked automatically before deployment. This proactive approach transforms vulnerability assessment from a one time task into a continuous security practice, giving organizations confidence that their containerized applications remain secure and reliable. Now, let's move into our hands on lab where we'll scan both a clean and a vulnerable Docker image, analyze the results, and see how this knowledge helps strengthen container security. The objective of this lab is to perform a comprehensive vulnerability assessment on Docker images using Trivy. You will learn how to scan container images for known vulnerabilities, misconfigurations, and missing patches, interpret scan results, including CVE details and severity levels, and apply these insights to strengthen the security posture of containerized environments before deploying them into production. Now, let's look at a real world scenario. Sophia, a certified ethical hacker at SoftTech Corporation in Toronto, has been tasked with evaluating the security of the company's containerized applications. Since Docker is central to their deployment pipeline, leadership is concerned about hidden vulnerabilities in base images. To address this, Sophia will demonstrate a vulnerability assessment using Trivy, scanning both secure and outdated images to identify CVEs, misconfigurations, and severity levels. This session aims to raise awareness among developers and their DevOps teams about the importance of image scanning and the best practices for securing containerized environments. Before we begin the demonstration, let's quickly go over the lab requirements. For this lab, we'll use Kali Linux as the operating system. The tools we need are Docker to run the containers and Trivy to scan them for vulnerabilities. We'll work with two images, Ubuntu, which is secure, and an older version of Nginx, which contains multiple vulnerabilities. With these ready, let's begin the demonstration. Alright, so in this hands-on demonstration, we'll walk through the process step by step. First, we'll set up our environment and install the required tools. Then we'll scan a clean Docker image like Ubuntu to see what a secure image looks like. And after that, we'll scan an older vulnerable Nginx image and analyze the results to understand how Trivy highlights risk. So let's get started with the lab demonstration. Alright, so open the terminal by clicking the terminal icon on the top left and select root terminal emulator. An authentication window has appeared. Now enter your root password for Kali Linux and click authenticate. So over here we're going to type our password and click on authenticate. Alright, so first we're going to update and upgrade our system packages by running the following command. Alright, so we have successfully updated and upgraded our system packages. Now we're going to execute the following command to install Docker in Kali Linux. And press enter. Now after installing Docker, we can install Trivy. by entering the following commands. Now, if a pop-up appears like this about outdated libraries, press tab to highlight OK and then press enter to continue. So we have successfully installed our Trivy tool in Kali Linux. Let's scroll up and look at the commands that we entered. So over here, first we installed wget and gnupg. Now wget is used to download files from the internet and gnupg helps us handle security keys. Then we download Trivy's official security key and save it on our system. This makes sure that the software we're installing is authentic and hasn't been tampered with. Next, we add Trivy's repository to our list of software sources so Kali Linux knows where to fetch it from. And after that, we update our package list to include the new repository. And finally, we install the Trivy itself. At the end, we can also verify the installation by checking Trivy's version. So let's do that. For that, we're going to paste this command and press enter. And here you can see that we have successfully installed Trivy. Now let's pull the first Docker image by running the following command. Docker pull Ubuntu. Once the image is pulled, we will perform a vulnerability assessment. So let's execute the following command. Trivy image Ubuntu. So as you can see that when we scan Ubuntu image, Trivy reports 19 vulnerabilities. 7 of them are low and 12 of them are medium. This shows us something very important. Even official and widely used base images are not always free of security risk. While these issues may not be critical or high, they still highlight the importance of regularly scanning and keeping images updated. Now we can move on and analyze an actual vulnerable image. For that, we're going to pull a vulnerable image by entering the following command and press enter. Now we're going to use the Trivy tool to scan the image. For that, we're going to run the following command. So the scan have been successfully completed, and this time the scan reveals 455 vulnerabilities, categorized by severity, with detailed CVEs listed. This demonstrates how Trivy helps us identify risk in container images. So, in this demonstration, we saw how Trivy scans Docker images and highlights vulnerabilities by severity. Our scan of the Ubuntu image showed that even widely trust-based images can contain issues, while the older Nginx image revealed a much larger number of risks. This reinforces a key point. No image should ever be assumed secure without verification. By making vulnerability scanning part of your workflow, you can detect problems early, fix them before deployment, and ensure your containerized applications remain safe and reliable. In this session, we explored the importance of container security and learned how to perform vulnerability assessments on Docker images using Trivy. We saw how a clean image like Ubuntu shows zero issues, while an outdated image like Nginx reveals hundreds of vulnerabilities with detailed CVEs. The key takeaway is that regularly scanning your container images is critical for preventing hidden risk from entering production. By integrating tools like Trivy into your workflow, you can detect and address vulnerabilities early, ensuring a stronger and more secure container environment. That concludes our session for today. Thank you for watching this video. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel. And also share it with your colleagues or friends who might benefit from this information. If you have any questions or topics that you would like us to cover in the future videos, feel free to leave a comment below. Your feedback is very valuable to us.